functions such as facial recognition, fingerprint recognition, speech recognition. So these are the type of AI. Most of us now use smartphones that have fingerprints to access your phone, your facial recognition to access your phone. So all those are AI, but they fall under the category of narrow AI. What that means is that AI, those kind of machines, does not have ability to do something else other than the specific task that have been assigned to do. Example, your fingerprint. It can only do fingerprint. It cannot do facial recognition. So that is an example of narrow AI, and it is sometimes referred to as weak AI. So let's say in the case of facial recognition, the AI is trained, right? The AI is trained to identify and verify a person's face from a digital image or video source. And this uses machine learning, a subset of AI, to analyze and compare facial features with those in pre-existing database to determine your face, because you have trained it. So the process of you registering your fingerprint, you are training the machine learning on that, the machine on your phone to recognize your fingerprint. And that is why it is only your finger that your phone will recognize to be able to have access to, to get into your phone. So that moment of you fixing your fingerprint to register it, you are actually training the machine on your phone to be able to recognize your finger. So that process is called training, and that is what an example of narrow AI. So the next type of AI we have is the general AI. As you can see, so most of these things we will be talking about, they all encompasses what you have typed in the chat as being AI. So the general AI now, as opposed to the narrow AI, is referred to as the strong AI. You know, we say the first one were the narrow AI. Now, the general AI is a strong AI. What does the AI do? It is able to learn reasonable. This AI, it's able to learn reason and understand complex concepts, just like human. An example of this is we have Siri, right? And Siri was developed by Apple, and Siri can answer questions and make recommendations. We also have ChatGPT now, another example, right? And other AI like that can compete in sports, play video game, volleyball, and all that. So all those are categorized under general AI. Siri, the AlphaGo, we have robotic like Sophia, which is the first humanoid robot that was developed. So Sophia can interact with you. It can be used for entertainment and all that. You hardly know that Sophia, it's a robot because of the way it was created. So now the second one, it's the super AI. As the name implies, right? It's a super intelligent AI that is capable of surpassing human intelligence in all ramifications. So remember, the general AI, it's all this AI that has the ability to do everything that human being can do, right? You know, they can do everything that human can do, even better than how human can do them sometimes. But now, the super AI is a super intelligent that surpasses human intelligence, and in reality, super AI does not exist at the moment. I'm not sure about tomorrow, but at the moment, it's not available. So we are talking about future AI. So we can refer to super AI as also future AI. So yeah, they do not exist, but we have seen how they feel, you know, and currently there's significant debate among scientists and AI researchers about whether it is possible to create such an AI and what the timeline for such a development might be, and if it will be created at all. But an example of it is, if you have seen this movie, Skynet from Terminator, the Terminator film series, which is an AI system that becomes self-aware and decided to exterminate humanity. So that is super AI, that is future AI, and there is a lot of conception. I mean, there is a lot of debate about should we really make this AI that will supersede human? So what if this AI ends our life one day? We have seen an example from the Skynet movie. So that is something for you and I to think about. So if you find yourself in a position where you have the ability to be part of the super AI development, think about it. And that is why, because of this now, there have been a lot of agitation and discussion about AI being fair, fair AI, responsible AI, and all that. So that's why most of these discussions are coming, because of the foreseeable features of what the AI, super AI can do. So now, I haven't talked about the different types of artificial intelligence. Let's look at the benefits of artificial intelligence in health. There are several benefits of artificial intelligence in health, but the most important that, is being beneficial to people nowadays is speed. So incorporating artificial intelligence into AI enables faster turnaround time. So AI can quickly, get patient genetic metabolomic and bioinformatic data, which is important in the case of an emergency to avert complications. As you and I know, sometimes, especially in Africa or in developing worlds, when you go to the hospital, if you have to take an X-ray or if you have to do a medical examination, your X-ray is being taken, there is no radiology to read the X-ray for you at that moment. You have to keep going, coming, or wait. You're at the mercy of the radiologist, who is not readily available to interpret your scan result. But that is where AI comes in. So AI will be able to, feed this information to the AI. It will be able to give you results in seconds, which you don't have to wait for anybody to get an idea of what is wrong with you. Of course, you will still need the health professionals to interpret, and also, prescribe what's next, even though AI can also do that for you. So another thing another benefit of AI in healthcare is improved accuracy. It provides quick diagnosis of diseases, and this is an important way to achieve this. A medical personnel must obtain precise data to enable them to make crucial decisions. So if the process of you getting crucial data takes time, it will not help you to make faster decision. And some diseases require early diagnosis so that they can be treated early. Otherwise, once they deteriorate, it might be too late to manage. Yeah, AI has been beneficial in personalized medicine. As you know, human differs in their genetic and physiological and behavioral makeup, which influences diseases process and treatment responses differently. As such, each person must receive individualized care. So what this means is, because Mr. A and Mr. B are human and both of them are having the same symptoms, headache or whatever symptoms that they have, does not necessarily mean that the same medication or they will be treated the same way. No. So that is why personalized medicine is important, because when you have all the information about patient A and also all the information about patient B, it will be able to guide you on what appropriate treatment is required for each one of them, because patient A might be suffering from other diseases that are hidden that you are not aware of. You're only aware of that, okay, patient A is having a headache, patient B is having a headache. But what are other underlying ailments or something that is happening within their body structure based on the differences of human beings? So this is why personalized medicine, AI is improving personalized medicine, because it helps you to analyze individual person and determine the type of treatment that can be curated for individual, regardless of if A and B are having the same symptoms. Another useful of AI is in clinical guidance. AI is used to evaluate potential patients for clinical trials based on their combined medical information. It can assist in analysis of patient trial reaction. Again, still part of the importance of AI, improved diagnosis and treatment, precision. It's improved treatment, it's improved diagnosis. Just as AI is prevalent in our everyday life, so is AI important in technology for healthcare especially. As of today, AI is primarily utilized to increase speed, accuracy, improve diagnosis of treatment in healthcare realm. So improving diagnosis, AI algorithm can analyze large data sets, regardless of, we are talking about millions of data. So can you imagine how long it would take human personnel, professional medical healthcare practitioners to deal with few number of data, not to talk of millions, not to talk of billions of them. So this is what AI can do. It can analyze large data sets of medical patients in a record time and, combined with their medical images, patient record, genetic information to identify patterns and markers that may not be immediately apparent to human clinicians. So early detection, for example, AI can analyze mammograms to identify early signs of breast cancer on chest X-ray, and it can also interpret electrocardiograms, that is the ECGs, to detect irregular heart rhythms that can lead to cardiovascular disease. I'll give more example on this as we proceed forward. Again, it's been used to enhance patient care in all ramifications because by analyzing patient data, including their general medical information, AI can develop personalized treatment plans tailored to individuals' unique needs. Again, like I've said before, unique need. This is very important. You don't generalize. When you're treating people, because different people have different body composition, you have to be specific to know that A and B may not sometimes get the same treatment. So by way of doing this, the AI, it's very precise. And that is known as precision medicine. It ensures that patients receive the most effective treatment while minimizing side effects of those. So another one, AI has advanced the medical research and also even drug discovery. So medical research and drug discovery through AI involves leveraging computational techniques to accelerate the development of new therapies, which improve understanding of diseases mechanism and optimize treatment strategies treatment strategy for individual patients. So overall, we are saying that AI's ability to analyze complex healthcare data, and again, I emphasize complex, because healthcare data are very complex, especially when you work with electronic health records. It helps to identify patterns and generate actionable insights that has potential to revolutionize diagnosis of treatment, which might lead to improved patient outcome, reduce healthcare costs, and also enhance the ability of care. So these are very important benefits of AI in healthcare, and which needs continuous improvement as the year goes by. Having talked about the benefits, let's look at some of the applications of artificial intelligence in healthcare. I think I have briefly mentioned some of this, but just to have an overall overview of them. And as you can see in this figure, we have the application of AI in healthcare. It can be used to diagnose. It's been applicable to diagnosis of diseases. We'll talk about this specifically in our next slide. It can be used for medical diagnosis, medical image diagnosis. I've mentioned also before, drug discovery, personalized medicine that I've said, medical robots, those are robots that help in, the chatbots, medical online assistants that you can key in information, give it your symptoms, and it can relate to you. But once it see that you require referral, then it cannot refer you and for further treatment. Then electronic health data records. So this is a very important health record information of patients, very large data set of patient records. So it has history of since when a patient is born until the day he comes for treatment. So this record, as long as you have registered with the health record health provider, you can have this record in advanced world, of course. And I hope that we can get to that level in Africa where we'll be utilizing health records so that, and what this help is that if you are using an hospital in, let's say, in anywhere, I'll take South Africa, for example, my South Africa people, Ngiyabonga, I greet you all. So let's say you are in Joburg and you are having your health record information, everything is in Joburg, and you needed to access medical health in Durban, in KwaZulu-Natal. So you don't have, the hospital does not have to go and start doing all the tests and all that for you again if you had already done this, because they would already be incorporated into your online information, online records. See, this is why electronic health record is very important, and it's helping. It's a very large data set of patient record, which is very, very enormous and is very useful. It's help in quickly understanding patterns, concepts that can help you to diagnose patients easily. Also in clinical trials, before patient can go for clinical trials. For example, during COVID, there were some people who were, who wanted to be used for clinical trials, right? So AI would help you to analyze those patients, their medical records, so that there is any underlying ailment that can impact the trials, because some ailments might not make you to qualify. So essentially, AI is being used. It's being used to select patients that can go for clinical trials without any adverse effects. And if it say that you are not qualified, you are screened out so that there won't be any complication. Also, prediction. So AI can be used to predict outbreak of diseases in medical field. Okay, just like I've said, that one of the importance of artificial intelligence in healthcare is diagnosis of diseases using AI. So here you can see a flow pattern of how AI is being used to diagnose diseases, and I'll walk through this. So let's say this is our patient right here who is having some symptoms, maybe sneezing, cough. Now, whatever these symptoms is, it's either it is mild or it is, an acute symptoms. So when using AI, is if it is mild, you are having a symptoms, you determine that it's a mild symptoms. So usually you do a Google search of the causes of the symptoms. If you're having headache, sneezing and the likes, you put in what are the, probable causes of this, because of these symptoms. Why am I getting these symptoms? Then you proceed to getting preliminary diagnosis from an online assistance. So we can say this again, the AI robots, online robots that we talked about in our previous slide. And now, so this online assistant, what it does is once you give it the cause, I mean, the causes of the symptoms you are having, all this information that you have Googled, right? So it now does what we call data collection via questionnaire. Already there are data that has been collected, questionnaire. It also search other databases online to compare with what that has come. And after getting all those information using chatbots and the likes, these results are compared with pre-existing data that has been collected, that is stored in the data, that is in the database of the AI that is being used to train it. And once this is compared, then the diagnosis, the probable diagnosis is being decided, and this is sent back to where you wanted to get a preliminary result, where, so the process of getting preliminary result encompasses all this process. And once this is gotten, then you confirm diagnosis and treatment from experts. So once this is gotten, an expert will now confirm, okay, yeah, based on A, B, and C, you are likely to have flu. Based on A, B, and C, we think you have COVID. And from here, treatment will begin based on what have been diagnosed, right? Now, how about in the case of when it's an acute symptoms? So in the case of an acute symptoms, you contact your healthcare provider, healthcare professional. In this case, we're talking about doctors or whatever it is called in your locality. I mean, doctors especially. And so once you contact the doctor will want to get diagnosis. So the process of the doctor getting diagnosis also encompasses some of these here. And that is one is to get clinical history and data gathering. And this is when you go to a doctor, he asks you, when did this start? Have you felt this before? What did you eat last night? Did you sleep well? Did you, all those kind of things. Those processes are actually data gathering process. Now, after the doctor has gathered all this information based on the symptoms and the information he or she was able to gather, he will now prescribe and he will do physical examination on you. And that is where you see they'll test your heartbeat, your eyes, you see them, they open our eyes like this and all that. So those are physical examination, and also recommend blood tests to further, have justification for whatever he has, gathered information about. And all this information are now processed using a trained AI that's already trained. So those information will be supplied to it. It looked at it, do all the manipulation within the trained AI. And as with before, the predicted diagnosis from the AI will be sent back to the doctor where he wanted to get, the diagnosis. So now the AI will determine, yes, based on this, based on the test, based on the data gathering, and in related to what I have in my database and what is obtainable out there, this patient is having flu or this patient is having COVID-19. And also the doctor, based on all his own data gathering and the result from the test, the physical examination and test result, would have also determined the causes, predicted the diagnosis. So this comes here with what the doctor also has predicted, has diagnosed you for, and it compared those results, and using those results, the result is communicated to is communicated to the patient, and then based on that, they will set up treatment plan. So this is very precise. It helps you to actually, you have done all the necessary examination, you have done all the tests, you have compared notes, human and AI. So you will be very precise and confident about the type of feedback you give to patients with respect to what they are feeling. And that way, you will not be doing a trial and error with respect to what medication plan or what what medicine you prescribe for this patient. So that is one very useful aspect of artificial intelligence in healthcare. So another one would be uses of artificial intelligence for medical imaging diagnosis. So just like before, now, for instance, we have a patient's chest X-ray. As you can see here, So we want to determine probably this patient is having some symptoms, chest pain, or, irregularity of the heartbeat or whatnot. So now this really happened in two phases. So in the case of this, it is referred to an expert. So an expert would collect all the medical patients, you see the X-ray, will examine it physically, and the expert will say, okay, based on this, I think there is abnormality in your right upper lobe or your left upper lower lobe and all that. The medical expert predicts their diagnosis. Now, this also, while that is going on, the image is also sent to the AI model to predict, right? So the AI will use this information, is going to train on the data that is being supplied based on existing previously knowledge that is already in the database, you understand, that has been trained with, and then it also predicts, the model also predicts the diagnosis. So we have the diagnosis from the patient, from AI, and also from the doctor. So the doctor now compare both diagnoses and make a final decision to communicate to the patient based on what has happened here, what has happened here, based on this, we think it is atrial fibrillation. I mean, irregularity of the heartbeat, or we think you are having pneumonia and all that. So that will help them to precisely give the right treatment, knowing confidently that they have the right diagnosis of what is happening. Also, we mentioned about the drug discovery. Yes, AI offers a exciting opportunity to expedite drug development with its ability to discover novel targets. Drug discovery is a daunting process that demands significant resources and takes years to accomplish. However, this process has undergone tremendous advancement due to the integration of AI technologies. As we might have all known, the fastest vaccine that was developed was the COVID-19 vaccine, particularly the biotech, the Pfizer vaccine, which is known as the tocilizumab. This vaccine sets the record by being developed and approved for use in just about 337 days from the identification of the disease of the targets. I mean, the disease is targets. So the rapid development was unprecedented in the history of vaccine, significantly surpassing previous vaccine medicine, like the mumps, which was the fastest one that was developed before, which took about 4 years from the development to approval. And this was in 1960. So you see how AI has helped that phase of quickly be able to determine all the necessary components and put together and determine the particular drug or dose of vaccine that can be effective for the COVID-19 pandemic than we had in 2020. So this is another tremendous use of artificial intelligence in healthcare. Okay, now, so we'll look at some of the case studies of AI application, and I bring up this because these are the ones that are more current now and we are more familiar with. So, like Google DeepMind, develop a mobile app called Streams, and Streams analyze patient data in real time to provide clinicians with timely alerts and insight so that they can improve the patient outcome. IBM Watson also, it uses natural language processing and machine learning combined algorithms to analyze patient data, medical history, and clinical trials to recommend personalized treatment plan. Apple, on the other hand, also leverage AI and machine learning technologies. So Apple Health Records organizes and presents medical data in a user-friendly format, empowering individuals to control their own health. And this is why these days now you see a lot of application on our mobile phone, on wearables, wristwatch, and all that monitor your heartbeat, monitor the amount of calories you have burned in a day, monitor your exercise and all that. So all those information, are useful, and they are all because of the application of AI in health. We also have Google Health medical imaging. So the algorithm analyzes medical images with high accuracy and is helping radiologists and clinicians to detect diseases earlier and more accurately than it used to be before. Microsoft also developed conversational agent that assists healthcare organizations by providing patient engagement and support. So all these are case studies of how AI application is relevant in health and should be more encouraged. Despite all these beautiful application of AI in health, of course, there are challenges that are accompanying this and which needs to be addressed, which are already being addressed as well. And so one of them is lack of computing power. As you know, training a robust AI require large amount of data. So, and big data application in healthcare require powerful processing for training large neural network models. However, standard desktop computer often lack the necessary computation and capabilities, leading to overheating. Sometimes it crashes or prolonged training times. Some of us would have tried to, train some, model on our machines, and it takes like overnight for it to finish. And the funniest thing is, you find out that while it finished and you were sleeping, you put it on to run overnight. By the time you wake up in the morning, it has run into error. But if you have a very large and high computing power, once you press go, 5-10 minutes, you have you know where there is problem, what you need to address and all that. Not training for about 10 hours, then you come back, you see that there is a place that you have missed a line of code, or you didn't put the right quotations, which will make your code to work. So that is very challenging. So computing power is a very important aspect that needs, it's very challenging and needs to be monitored effectively. Privacy, data security. The medical field prioritizes patient confidentiality, and a lot of people have gone to jail, confidentially, privacy releasing information of patients. And that's why these days we have most of the medical record are de-identified, so that even if you see the record, you don't know who owns that record. So they are coded in such a way that you will not be able to trace those records back to that particular patient, because some of these data are used for training models, training and retraining. So it is important that they are de-identified and highly secured so that it doesn't get into the wrong hand. Now, another one is integration challenges. Integration of AI technology should be seamless with existing healthcare. So imagine in the field of radiologists. So where radiologists have, they are used to their RIS, and is it parts of software that they use for their own. So if you are building whatever AI you are building, you must be able to be compatible and to integrate into their system. So this way, you are making it easier for everyone so that you seamlessly incorporate it, and they'll be able to go through, use what they're already familiar with without having to start learning and relearning, which might be challenging for a lot of people. So that is also another challenge. And most of the models you see out there, everybody is training model, but how many of them are being integrated into healthcare? We all know the answers to that. So legal challenges, yeah. In developed country, there is always a case against doctors, against healthcare professional, against medical health provider and all that. And it's very challenging for professional, to the extent that even some doctors don't want to practice as they should because of all those things. Right now in the US, there is a lot of different states are having divided opinion as to whether to allow abortion bill to pass or not to allow abortion bill to pass. Some states say, yes, we allow abortion. Some states say, no, we don't allow abortion. So wherever you are, if you are in a state that say, we don't allow abortion, if you are a doctor and you dare try to perform an abortion, you might even find out that the person you perform abortion for will be the one to sue you at the end of the day. Yeah, that is how crazy it is. So there is a lot of legal issues, legal challenges, which needs to be tidied up, right? So yeah, so having discussed the challenges, what are the future of AI in healthcare? Very important, continuous advancement in AI technology, continuous advancement, continuous improvement. Of course, whatever we have today, we can make it better tomorrow, because as we develop model today, we see the challenges, the loopholes, we fix those and make our model better. So advancement, certainly the development of AI for health needs to keep advancing and in a better way. Another important option for future is collaboration between healthcare and technology industries. Technology, you have all the technology ideas, the medical people have all the medical and they know. So you have to incorporate, work together collaboratively so that you'll be able to serve the community better. Presently, I'm doing a project where I have different people from different teams. Some are doctors, some are consultants, some of us are computer scientists. So we work together. They tell us what is the meaning of this. So you are able to code those things in the terminology that they understand. Because you might not just want to put things in the way that the computer understands. Computer understands zeros and one. This is not the case in medical field. So the collaboration will help you to be able to integrate these things effectively. So potential impact on healthcare delivery and patient outcome. Issues such as data privacy, security, and the needs for regulation pose significant challenges in healthcare. So this is why we have begun to clamor for responsible AI in terms of fairness and equity. Okay, in summary, AI holds transformative potential for healthcare and is promising substantial improvement in efficiency and effectiveness. So, and remember, one of the popular questions among people about AI is that, would AI take people's job? If you want to take 30 seconds to just put in something in the chat, yes or no? No, I see no. Yes, let's do this in 30 seconds. Yeah, I see no. AI to take people's job? No, yes, no, yes, no, yes, no, yes. Exactly. And thank you very much for everyone that responded. And if you ask me, my perspective, none of you is wrong. However, AI is going to take some jobs, because the jobs that AI would take is if you refuse to, include AI in your work. AI is definitely going to take your job. I'll give you an example. In United States, we don't have, when you go to gas station and you pump gas yourself. And also, I think, so, and when you go to some part of Africa and Nigeria, we have pump attendants who will pump gas for you to your car. And, that is employment for some people. So that kind of employment is not existing here, because all the gas stations are automated. You have to do everything yourself. You put in your card, you buy gas, whatever amount you buy, you deduct that amount from your card, and everybody goes away. You take your receipt. So you are not waiting for somebody on queue that, oh, come and put gas of $1, $10 for me and all that. So definitely AI will take some jobs if you refuse to incorporate AI into your job or upgrade yourself to use AI. And remember, if you can't beat them, you have to join them. So don't be left behind. Try as much as possible to engage, to be part of, to incorporate AI into whatever you are doing, and be enthusiastic to learn whatever it is you might want to learn. So these are some of my references. Thank you very much for listening. So I'm happy to take some questions, and I'm confident that I have our mentor here, Professor Jude Kong, and other Blessings, Dr. Blessings, who would, do justice to your questions. Thank you.
Thank you so much, Dr. Mustafa. This was very informative and very exhausting. I'm sure that we are taking a lot back with us. Let us leave emoji or use the reaction button to leave an emoji for Dr. Mustafa just to say thank you. We will take questions now. So Dr. Mustafa, there's a question that came via chat earlier. We would read that, and anybody who has a question, you could raise your hand, we would unmute you, or you could put it in the chat and we would read it out to him. So Dr. Mustafa, Ibrahimu is asking, what is the state of the art on using large language model-based agents to automate clinical decision support? And what areas have potential to be automated using LLMs?
Yeah, thank you very much. So as you know now, AI is evolving, and LLM now is like the order of the day. So everyone is incorporating LLMs, and you see a lot of different different categories of like ChatGPT and the likes are coming out. And people are really utilizing that to their advantage. People use LLM now these days to train their models and to compare with other models. So in general terms, LLM, the state of the art on using LLMs, it's very updated with respect to these are models that are able to that give you response quickly. So using them to create, because some of us just use this, especially ChatGPT, for ask question, write my email, do this and all that, which is important. But people are really using LLM to train, to fine tune their models and get better results. So this is a very exhaustive section of using LLM, and I hope if other people can, shoot in to respond to this question. So I want this question section to be open to everybody, not just me alone, so that we can have diverse and rich answers to our questions.
So if you raise your hand, you can go ahead to speak. Just raise your hand if you'd like to speak or make a contribution. Ibrahimu was asking about how what is the gold standard on using LLM-based agents to automate clinical decision support, and what areas in healthcare, or maybe what LLM-based agents have potential to be automated.
Okay, so I'll just give you a short example. One of my colleagues yesterday, he used LLM ChatGPT to try to they identify food, right? So they use ChatGPT to be able to identify samples of food. They take samples of food items from different area so that ChatGPT can identify them. So what this does is, if you have the samples of food, this helps you to like if so. For instance, if you ask me what did I eat last night, it's exhaustive for me to be able to answer critically all the things that I've eaten and all that. But with the use of LLM and all that, I think that project was being able used to identify various types of food just based on the samples that were being trained upon. So exhaustively, LLMs have ability. It all only depends on how you are able to utilize and fine tune them on your model and exactly what you want to use them for. So they are being used to improve our models, of course, but then most importantly, you need to have domain knowledge of the area you are applying it to, because trust me, sometimes some of these LLMs, they are not perfect at the moment, but they are very, very useful. So if you don't have domain language, and that's why you see sometimes some people use it, and we are able to know that, look, this is what you have used, and the likes.
Okay, thank you for that input, Dr. Mustafa. And just in that light, I would add that because my background is healthcare. In terms of state of the art, you would see that with LLMs, I guess, one thing that is very healthcare specific is the importance of maybe giving a disclaimer or some kind of caution, especially with maybe if we're dealing with maybe using ChatGPT for recommending drugs or recommending what kind of specialist to go to or medical advice in general. It is important that we include some kind of disclaimers or cautionary tale to say, this is not accurate or this is just a machine or something like that. And I think that another gold standard practice when it comes to healthcare specific solutions would maybe be in terms of using LLMs in sync with human, just like you were saying, Dr. Mustafa, in sync with human knowledge, so that there's some kind of oversight and these models are not being used independently and we're not taking, decisive medical action, based on them. And so we have another question here from Stanley, and he wants to know, how do you take into account various aspects like anthropology, culture, religion, economy, etc., in the practicality of AI, especially in Africa?
That's a very good question. If you hear at the tail end of my presentation, I mentioned something about responsible AI, right, and all that. So this is a very delicate issue with respect to what is actually even classified as responsible, right? So because let's talk about religion. Your religion might be different from mine. Even within the same religion, we still have different opinions, right? So then what do you define as responsible for you to even come up with a responsible AI? Is it criminal? Some action that are criminal in Nigeria might not be criminal elsewhere. So this is a very so there will not be any general kind of assertion to respect with respect to what is being termed as a responsible AI with regards to whatever domain, either religious, anthropology, socio-economy, or cultural background. So it all solely depends on individual what you are, but definitely there are certain standards that everybody know. Murder, you cannot say murder is not every part of the world. Murder is a problem. But when you talk about the issue of what is it called now? There are diverse opinion. You see, you can say you are a man. I can say I'm a woman. So what is the responsibility in that? Everybody is entitled to whatever they believe and what to call themselves. So that is a very delicate aspect with respect to LLM. I mean, with respect to responsibility.
Thank you, Dr. Mustafa. So Tades, I think Doctor has answered your question in a way, your question on medical ethics and accountability. It is diverse, but we tend to try to agree on those things that are universally acceptable. But something that he also mentioned, that it is quite contextual. So we try to implement AI in healthcare solutions according to the context or to the context suitability. So we have a question from Majid, and she's saying, short of each Optum setting up their own website and streamline, I'm sorry, we'll take this again because I don't seem to understand it. We'll take this in the background. So we have a question from Julius via YouTube, and he wants to know, from the data point of view, what is our capacity as Africa to roll out AI in health, especially considering our data storage is still in print form, in analog?
That's a very wonderful question. That is a very wonderful question. And that is something that every one of us should be thinking about as Africans. What contribution can we make? In terms of what is our capacity, I don't think we have any. We don't really have something to be able to say that, yes, we can depend on this to, we don't have a robust data set, database, or cross-sectional information data to be able to say, we are there yet. We are not, and we have to accept that, and we have to all work together. I think that is one of the importance of this gathering, so that there's going to be collaboration. Everybody brings their idea together and we form it together. I was at a conference last year, December, the NeurIPS in the United States, and we had a very fantastic presentation from one of our scholars from Ghana. So when we had the Black in AI workshop, so it was a very interesting, and we decided in that conference, in that workshop there, that look, let's come together as Africa and share data. Because, for example, there was a project that was done in Ghana that did it with for palm fruit, right? So I asked the question: have you been able to test this model on palm fruit from Nigeria, on palm fruit from other African countries? So, and the answer for now is no. So if we can get data set, palm fruit data set from Ghana, get from Nigeria, get from Gambia, get from Uganda, get from South Africa, and we bring all those together, it will help us to make that model to be highly generalization, to be highly generalizable. You know, it will generalize upon all different data sets, not just data set that is, you know, only domiciled in Ghana. So it's important to all, so that we all come together and pool resources. And that's why we need to network. What are you working on? What am I working on? How can we put this data together and, you know, have it somewhere to help Africa? I think there's one of our colleagues, Dr. Georgia Obaido, and I think Dr. Blessing, Dr. Kenny, they are working on a project, the African South, Global South, putting a lot of data together so that everybody around the world can access it. And this is something that we all have to make contribution to. So that's a very good question. Thank you for that. So individual, everybody should try and do something in their own capacity.
Yes, just to buttress your point, first of all, can I, Olutola, can I add something?
Yes, of course. Please go ahead.
So just to buttress your point, currently we are in academic, we have different hubs. We have partnering countries that we're working with 9 African countries right now, where we are actually working with locally relevant data. So my contribution or addition to what you're saying about our capacity in Africa to look at considering the data that we have, it is important that, you know, meetings like this, people should know that if you are in every locality, you can start gathering data of any particular disease or any particular outbreak in that particular locality. So when we start creating data sets of our own, those data speaks to what is affecting us. It becomes easier. I did a research with some people in Nigeria where we created data sets. It's actually hosted on Kaggle for aquaponic fish ponds. And I can tell you that up to 200 people have actually used, different researchers have actually used that data set since we did that. And it was done in Nigeria, in Africa. So how we can tackle this issue of, you know, deploying AI in healthcare, especially to solving African problem, is by us at our local level, start building data sets, because AI cannot work without data. If we start building data sets and start hosting data sets, people can just, you know, Google and see a data set that relates to a particular problem that they want to solve in that area. Then it becomes easier to have something to do. Someone in Kenya or someone in Kenya or someone in Tanzania or someone in South Africa, maybe someone in Soweto in South Africa or some villages, and there are researchers that go there to gather data and put it up there on the web for people to download. Then it becomes easier for researchers all over the world to have access and solve your problems. So that is what I can say about that. Thank you.
Yeah, thank you, Doctor. And I think Jim is just buttressing the same point, because he's saying many African countries are working on clinical data repositories and health information exchanges, which of course can be the basis for building this model. So Andreas, you have your hand up. Please unmute and go ahead.
Yes, thank you. Thank you, Dr. Mustafa, for the presentation. I would like to know, I don't know if of the scope, but when using AI and there is some training models, normally the most of the people say you need like a sample of 10,000. And I don't know if that is true or is it based in some I don't know, linear regression or whatever mathematics algorithms are used? And the other question is there any clinical trial that is being used now lately to like prove the evidence base of the different digital technologies of AI used in healthcare that gives more effectiveness and accuracy for the model used? Thank you.
Thank you. Let me speak to the data set thing. Of course. So yeah, like I mentioned earlier on, to build models, you need data. And to build reliable model, you need reliable data, not just a lot of data. You can have a lot of rubbish data, right? So you need reliable, very good data and a large amount of them, as much as possible. The more data you have, the better your model, and the better the generalizability of that model. So having said that, I am not aware of a certain number of data that is enough. So it all depends on what domain you are applying, you are building the machine learning and all that for. But what's important is you need a lot of data, and you also need not just a lot of data, but a lot of very good data. And and that's why sometimes there is also a process called data augmentation. So this helps to augment your data so that if you have limited data set, you can use them. This is another way of augmenting your data, is by using pre-trained model to fine-tune your small data on that pre-trained model that has already been trained in probably in a different domain. Like if a model have been trained to identify cars, types of cars and all that. So that's classification. So you can also fine-tune that model on your data set, even if it is small, and you can still get a reliable result. So to your second question about, can you remind me again, what's
Yeah,
about
no, like
clinical trials?
clinical trials that are used like to give more evidence-based in the use of any certain type of AI used in healthcare to be safe or have a good quality.
Yeah, so like I give example of some use cases, models developed by Google, IBM, Apple. So it depends on the domain you are looking at. There are a lot of there are a lot of very good trials out there, clinical trials, and also other trials to buttress the importance and use of AI that has been used in different fields. But specifically, so except you want to mention particularly an area, and I'm happy if any other person can make contribution to this.
Yeah, well, it's because I read lately, for example, that random clinical trials have been used for AI to try the effectiveness, but they lack some time with the economic problem of making the right cost effectiveness. Like AI is a technology that's extremely expensive to say. So maybe you can have a great model and you invest a lot of money, but then the inversion doesn't come back. That was more my.
Yeah, I think.
Yeah. Okay, go ahead.
For me, so you're talking about the costs when it has to do with AI. Is that what you mean?
Yeah, I mean, like I read this paper that talked that it's been used randomized clinical trials to give evidence to the AI in healthcare. But the problem is that lacks of the economic view. So maybe like they're effective to try that the model use is effective in healthcare, but that doesn't include the economic cost and part of the cost effectiveness of the technology.
Yes. So it still boils down to building our own locally relevant technology and using our own locally relevant data to build our models and technology. So if an AI tool or technology is built in America and someone in Africa wants to buy it or want to, deploy that services in Africa, the person will definitely pay high because, I mean, the cost of trying to deploy such technology in your local area is going to be, it's going to be much. Then if we have our technology and it's built in Africa, then definitely it's going to be cheaper. It's going to be cheaper to manage. It's going to be cheaper to deploy because it's actually built with a target that Africa, considering the technological lags in Africa, then when they are building it, they can consider all that. And that is the reason why, we are having a meeting like this, which will, awaken that mindset of trying to look into what we can do for Africa and in Africa. All right.
Right.
Yeah, thank you, Andreas, for that. And Dr. Mustafa, I think that the point she's trying to make about cost effectiveness of AI solutions is very much in line with the last question we're going to take, which is from Hasina. Because Hasina is trying to make the point to say AI for eye health service delivery at the level of supply chain is causing negative income-related impacts for optometrists in South Africa. So she's saying every optometrist has their own websites or their own procurement channels, all of which is kind of AI mediated or AI facilitated. And then at the end of the day, there's just some kind of confusion, and she's trying to understand how to join the AI revolution when it's kind of creating a negative economic impact instead.
So that seems a little bit long for me to catch up on.
Just trying to make the point of AI, instead of bringing streamlined processes and improved quality, service delivery, is on the contrary bringing a kind of fragmentation within the health system, because everybody's trying to create or use an individualized AI-based system or AI-facilitated system. And at the end of the day, the overall cost is increased because we're all trying to do something AI. And, and at the end of the day, there's more resources being used instead of the cost effectiveness that we would have expected AI to give as a result.
Oh, okay, yeah, I think I have an idea now. So what that means is, look, we are bound to spend more while we are doing trials, trying to understand things and all that. But once we get to that level and you get a better and a good model and AI out for solving any particular challenges in health, then it becomes cost effective. But in the process of trying to get it right, we are in the try and error phases, you would definitely spend more. It will cost us more. So when we talk about cost effectiveness, it will be the end result once you have the AI doing exactly what you want it to do. I'll give you an example in the case of chest X-ray diagnosis, right? So if it's definitely if you don't have a model that can analyze and predict accurately the disease that or the abnormality, the irregularity that is on the chest X-ray, you keep spending more. And you look at places like Africa where there is no standardized way, or there is no AI that is being used to analyze chest X-ray. So people spend more by coming, look, you took your X-ray, but it takes a lot of time for you to get feedback because the doctor is unavailable or the X-ray machine is not working. So you keep spending a lot of money going forth and back to get to the hospital, money, time, and all that. So all those processes will be exhaustive and they are very expensive. But once you have like AI that can accurately detect, manage, and interpret your X-ray result, you don't have to wait for any radiologist before another person can, the lead radiologist before other radiologists in the lab can interpret your result for you because it has already been generated. So while we are still in the process of getting things right, we are bound to spend more. So, but once we got it right, then it will be cost effectiveness. That's what that terminology means, and if I understand your question very well.
Thank you, Dr. Mustafa. Thank you very much to every one of our attendees. We do see more questions, but we are way behind time right now. So we will take these questions. We are noting them and would answer via social media. Our next session is next week, same time, same link, which would be on an introduction to machine learning. We hope to see every one of you there. And just as a last bit or as a takeaway, especially because we have healthcare professionals here, we see that Dr. Mustafa has told us a lot about the kind of solutions and the kind of revolutions that AI can do in healthcare. But as health professionals, I want to remind us of the responsibility that we have to identify the problems. I actually did attend a seminar earlier where the message was, for AI in healthcare to work, we need to go from problems to solutions. So get into the typical African scenario as a doctor, as a nurse. What is this process that is so burdensome? You know, what is this low quality delivery that we're doing? What is the problem? And then how can AI help us to solve that problem? Forgetting completely about how to build the algorithm or how to build the solution, just what is the problem? And then talk to somebody, right? So Dr. Mustafa, everyone is asking for maybe your LinkedIn details, if you can put them in the chat, maybe your social media handle. And you can talk to people like Dr. Mustafa, okay, to say this is a healthcare problem and how can AI help us solve it? And it's because it's not always about this is an AI solution that was done in the US or that was done in Australia and we want to do it in Nigeria, right? Or Africa or Cameroon. That's not how it works. It's actually a bit more sustainable, especially when we want to solve problems of cost effectiveness and contextualization, to start from the problem to the solution. So healthcare professionals, this is our responsibility. This is our assignment. Please join us next week, same link, same time, to learn about machine learning, which is a bit about the hardcore side of AI. Again, we are very thankful to you, Dr. Mustafa, for imparting this knowledge. We are going back, having learned a lot. Thank you so much. And we hope to see every one of you next week. Bye to everyone.
Thank you.
Thank you.
Thank you.
Yes, Dr. Mustafa just dropped his contact, I think his LinkedIn name in the chat. So if you can copy that quickly and reach out to him via LinkedIn.
Okay, bye guys. See you next week.
Bye. Thank you all for having me. It's nice spending time with you.
Are you ready to revolutionize healthcare in Africa? Digital Health Africa, in partnership with Africa Canada AI and Data Consortium, welcomes you to the AI in Healthcare webinar series starting May 4th. This groundbreaking webinar series will be taking place every Thursday and Friday throughout the month of May. Led by experienced instructors and industry professionals, this series is designed to equip healthcare professionals and students with essential AI knowledge and skills. From understanding AI concepts to building machine learning models, participants will gain practical experience and ethical insights to drive innovation in healthcare. Discover the transformative power of AI in healthcare. From personalized treatment plans to predictive analytics, AI is revolutionizing how we approach patient care. Join us as we explore how AI is bringing unprecedented innovation to the field of healthcare. Don't miss out on this opportunity to be at the forefront of AI-driven healthcare. Register now and let's shape the future of healthcare together.